In this video, we will do a real-time facial landmark detection with OpenCV, Python, and dlib. Dlib is a C++ library used for which contains machine learning algorithms and many functions relating to computer vision applications. And we will use a shape predictor. The shape predictor is that of dlib model. We have a dlib model used. I downloaded the file and put it into a model directory. And then we have a detector. We will use the native dlib get frontal face detector function, which will be used to detect a face-like structure in a frame. And I have modified the code here. In this video, a sensor was used, while for me I'm using my inbuilt laptop camera, so I'm using the function video capture. You will see that I will show you the results of the demo. So the frame is loaded and it is detecting in real time, and I have converted the frame captured from the camera to grayscale for processing. I'm also showing you the grayscale frame, which is here. I use this command in imshow to show you the frame. I use the dlib detector to detect faces in the grayscale frame, and if these four rect in rects is used to determine whether to use every rectangle, that is a bounding box. If a face is detected from the detector, it will give a bounding box will be detected in the frame if there is a face, and for each such rectangles there can be multiple detections, so we can have two faces in the frame also. So for each rectangle, for each bounding box, I'm using a predictor to predict, that is the dlib predictor, to predict the facial landmarks in the bounding box, and the bounding box is the region of interest. So we are using the predictor, that is the dlib model, to extract the facial landmark features. So dlib identifies the face by this 68 points coordination system. If you count all these red points, it will be of number 68, and every face part has its numbering associated with it. So for example, I have the jaw starts at the point 0 to 36 to 16 to 17 for an example, and the eyes too has its own region section for the coordinate points. And now, after predicting this 68 coordinates from that particular frame, it is actually a shape object. We will, for manipulation and calculating, to ease the calculations, we need to convert that shape object to an array. For that we use a shape to NP, that is Numpy array, using the face utils library, and with that we obtained as a result an array. So shape is now, where is the shape? Shape is now an array. This shape now is an array, and it is of size 68 by 2 because the shape previously had two attributes, x and y. We access for each point we access the x and the y, and we store it in the array. And now for every tuple, this is a tuple, for every tuple in the array, so the array, it is an array of tuples actually. So for every tuple we simply draw a circle using the circle function, and it is we give it a color red, BGR, or is set to the maximum. For example, if I want to terminated. If I want to give it blue to detect to make the shape predictor detect the points in blue, I'll give it 255 and I'll change this to 0. You will now see the points blue, and in this program there is a little issue. If the camera doesn't detect the points detected from the predictor, it won't show the image. It doesn't use the imshow function to display the frame. For example, here it's blocked, and I will just correct that. So if len of the rects is greater than 0, so I'm ensuring that there is at least one bounding box. Tab. Then it will execute this section, while if else, if it doesn't, still it will show the frame even if it doesn't have a face, that is a bounding box, and it still waits for the key. That wait key. And if I use I will use the key Q to break the loop. Let's just give it a try. There was an issue with the previous video, and let's run the demo right now. So now we use continue instead of break. So even if it won't be detecting any face, it will still show the current captured frame. So as you can see, if I cover my face. It's still displaying the frame, and I press Q and it terminated the whole program. So this was a demo for real-time facial landmark detection. Thank you.